Hello. In this video, we're going to look at a particular type of function or relation, called a function. So a function is when each value in the domain, now remember the domain values are our inputs, corresponds to a single value in the range, which are the outputs. So put another way, there is only one output possible for a given input. This is how we tend to think about math in general. If I have a particular problem, there's only one answer possible. So looking at some examples here of equations that represent functions, if I have y equals x squared, where x is my input, no matter what number you give me, if I square it, there's only one possible answer. On the other hand, if I consider y squared equals x, again, if x is my input, there are two possible inputs that would give me the same output here. So for example, if my input is 25, my output is what squared would give me 25. So that's 5 or negative 5 would both give me 25. So two possible outputs. If I have y equals the square root of x, or alternatively, if I have y equals negative square root of x, each of these specifies a particular root, either the principal positive root or the negative root, in which case there's only one possible answer. If the input is 25, the square root of 25 is 5, one possible answer. It's not a function if both roots are allowed, plus or minus, not a function. This is how we would isolate y in the first instance. The horizontal line y equals 6 is a function because no matter what our input, there's only one possible output, 6. Input of 27, output of 6. Input of negative 392, output is 6. Doesn't matter what my input is, there's only one possible output. On the other hand, a vertical line such as x equals 6 is not a function because that means that no matter what the output, it always came from an input of 6. So my input of 6 can go to an output of 7 or an output of negative 35 or anything really. This is made up of the points, all of which have an input of 6, and then any output. Graphically, this one on the left is a function because no matter which input, so no matter which x value I go to, I can only ever find one y value that corresponds to it. X is over here, there's only one y value that corresponds to it. Whereas in the second case, the graph on the right, if I find some x values, so if x equals 5, there is only one possible output. For an x input of negative 5, there's only one possible output. But if I have an x input, for example, of negative 2, well, the output could be this point down here below the x-axis. It could be this point here between about 1 and 2, or it could be this point over here around 4. There are three possible outputs for that one input. So this is not a function. Typically, we would say graphically something is a function if it passes the vertical line test. In other words, if I can draw vertical lines and they're only ever going to hit the graph once, that is a function. If I can draw a vertical line that hits the graph more than once, that is not a function. If I'm looking at coordinates of points, the one on the left, the set of coordinates on the the set of coordinates on the left does describe a function because every input, so input of 0, well, that only has one possible output. Input of 2 has only one possible output. Whereas in the second set of points, the one on the right, if I have an input of 5, there actually are two possible outputs here. Input of 5 can lead me to a 5 or a 6. If I consider what this looks like in a mapping diagram, my inputs in the first case, the different inputs here are 0, 2, 4, 6, 8, and they all lead to unique outputs. So 0 goes to 5, 2 goes to 5, 4 goes to 6, 6 goes to 7, 8 goes to 1. It doesn't matter that two inputs lead me to the same output. What matters is if I go into this input bubble, I know exactly where to go from there. Whereas in the other case, if I have 5, that can lead me to 5 or 6. If I go into the input bubble, I'm not sure which of those two arrows to follow. So 3 then goes to negative 1, 6 goes to 7, and negative 2 goes to 1. So as soon as I have any single input that leads to more than one output, in other words, repeated x values, then I do not have a function. If I do have a function, we can use something called function notation. And this is kind of what this looks like here. F in this instance, so this F and the brackets x, this does not mean a multiplication. F is referred to here as the function name. And we can use different letters. Often we'll use letters that are relevant to the situation. So if I have a function to calculate population, for example, I might use a P. If I have just multiple functions, I might use F, G, H, G, using different letters. And the way we read this, F bracket X is read F at X. In other words, the value of the function. So the value of function F at input X is sort of the long way of saying that. We often will just say F at X, but what we're saying is the value of the function F. And the value of the function F is just a really long way of saying output, which would often be Y. So we often are saying, well, we're using F of X in place of Y. So this would be in lieu of writing Y equals 2X minus 5. Part of the reason we do that is to underscore that it is a function, but also to keep together the idea of input and output. So rather than writing if x equals 2, y equals whatever. So let's actually look at this example. So this would be f at 0, the value of this function at 0. So if the input is 0, 2 times 0 is 0 minus 5 is negative 5. So what I could say is f at 0 is negative 5. That way within that one statement, I have both the input and the output. So instead of having to actually write out if x equals 0, y equals 5, but negative 5, sorry, f at 0 equals negative 5 has both the input and the output in one little statement. So whatever is in the brackets, that is my input. So if the input is negative 5, 2 times negative 5 is negative 10, minus 5 is negative 15. So in other words, the calculation I'm doing, I'm replacing the x with negative 5, which means f at negative 5 is negative 15. This allows me to change my input variable as well. So in lieu of an x, what if I have a b? Well, then that's just a new function. It's just a function with a different input variable, 2b minus 5. So we could replace our input variable with input expressions as well. And this will be a particularly relevant thing to do when we start getting into operations with functions and transformations graphically in later math courses. But if my input is now x plus 1, well, then instead of multiplying 2 times x, I have to multiply 2 times x plus 1. That's the whole input. This creates a wholly new function. I can simplify it down to 2x plus 2 minus 5, so minus 3 when I simplify that. It's a new function that has been essentially transformed from that original one if instead of using input x, I use input x plus 1. I could even put a function into itself. So remember that f of x is 2x minus 5. So f at f of x, nested brackets here, is f at 2x minus 5. So again, that means the input, which was x, is now being replaced with 2x minus 5. So this is my input. 2 times the input minus 5 is 4x minus 10 minus 5, so minus 15 when I simplify it fully. Again, completely new function has been created, but it's essentially saying what would happen if I took f of x, which is the output of the function, and then I put it back into that function. So I put a function inside of itself. And I can work the other way around. If I want to find the value of x such that f of x equals negative 29, well, f of x, remember I have the statement f of x equals 2x minus 5. So if I replace f of x with negative 29, I now have something that I can rearrange to figure out what value of x would give me that function. So add 5 to both sides. I've got negative 24 equals 2x, divide by 2, and I get negative 12 equals x. So the value of x that would give me a function value of negative 29 is negative 12.